Hello students. So in this video, we are going to learn about we are going to learn about the FFT uh, by using decimation in frequency algorithm. Okay. So in this case, the Butterworth diagram is existed like this way. Okay. So here A and B is there. A and B is there. Okay. And this A and B. So the twiddle factor is existed here. W and K. Okay. So for this Butterworth diagram, so it is A plus B and it is A minus B and the resultants which is multiplied with the twiddle factor W and K. So like this way, in this decimation frequency algorithm, the butterfly diagram is works like this way. Okay. Now I'm going to explain this DIF FFT algorithm by using the same example, previous video example only. Okay. So compute the x of n sequence by using decimation in frequency FFT algorithm. Okay. So it is also consisting nearly 10 steps. Okay. So those steps are very important. So just remember those steps. So here also the one number of first one, the step one is nothing but the number of input samples are given by n is equal to 2 to the power of m. Okay. So here where m is integer, so number of samples are 8, 2 to the power of m, which is equal to, can be written as m is equal to 3. Okay. And we'll come to this stage 2, step 2. So the input sequence is in natural order. So the input sequence is in natural order. It's not in bits reversal order, so no problem at all. In stage step 3, the number of stages are given by m is equal to log n to the base 2. So here the number of stages are given by log 8 to the base 2, which is equal to 3. Okay. And step 4, each stage consisting of n by 2 butterflies. Each stage consisting of n by 2 butterflies. Okay. And the next step is input output samples. So here the input output samples are separated by input output samples which are separated by 2 to the power of m minus m samples. Okay. So totally our sequence is 8 samples, so number of stages are 3. Okay. So for stage 1, so number of samples are 2 power 3 minus 1, it is equal to 4 samples. For stage 2, 2 power 3 minus 2, that is equal to 2 samples only. For stage 3, it's 2 power 3 minus 3, which is equal to only 1 sample only. Okay. So here the 1 sample. This is a very important. Okay. And step 6. What is the step 6? And the total number of computations, the total number of complex multiplications are given by n by 2 log n to the base 2. The total number of complex multiplications. Okay. So which is equal to, by the n value is equal to 8. So 8 into log 8 base 2, that is equal to 12. That is step 6. And number of complex additions are given by n into log n to the base 2. Okay. So here the n value is equal to 8 log 8 to the base 2, that is equal to 8 into 3, that is equal to 24. Okay. And step 8. So step 8 is nothing but the number of sets or sections which are given by which are separated by, which are given by 2 to the power of m minus 1. So the number of sets of butterflies in each stage, which is given by 2 to the power of m minus 1. Okay. So here m is nothing but stage index. So if m is equal to 1, totally we have 3 stages. If m is equal to 1, the total number of sets in stage 1, that is equal to 2 power 1 minus 1, that is equal to 2 power 0, that is 1. Only one set only. So if m is equal to 2, so 2 power 2 minus 1, that is equal to 2 sets only. If m is equal to 3, okay, so 2 power 3 power minus 1, that is equal to 4 sets. Okay. Step 9, and the exponential repeat factor. Okay, for each and every stage it is also given by 2 power m minus 1. Okay, so it is same similarly the step 8 and the step 9 both are similar, but the meaning, the purpose is very different to each other. So in step 8 indicates the number of sets in each stage is given by number of the total number of sets of butterflies in each stage is given by 2 to the power of m minus 1. Whereas in exponent ERF, that is exponent repeat factor, which is given by 2 to the power of m minus 1, where m is another stage index. So for m value equal to 1 small m, so its value equal to 2 power 1 minus 1, it is equal to 2 power 0, that is equal to 1. So for m is equal to 2, its value is equal to 2 power 2 minus 1, that is equal to 2 power 1, that is equal to 2. For m is equal to 3, okay, 2 power 3 minus 1, it is equal to 2 power 2, that is equal to 4. So that is about step 9. And the last step that is quite important and interesting also. So that is a twiddle factor. Okay, so the twiddle factor. So the twiddle factor is a function of the stage index m, and it is given by k is equal to nt by, okay, 2 to the power of m minus m plus 1, where t is 0, 1, 2 and so on up to 2 to the power of m minus m minus 1. Okay, so that is one. So here there are three stages are there. There are three stages are there. Okay, we need to determine for each and every stage. So when m is equal to 1, when m is equal to 1, so when m is equal to 1, okay, so my t value is defined as 2 to the power of m minus m minus 1, so that is equal to 2 power 3 minus 1 minus 1, that is 2 square minus 1, that is 4 minus 1, which is equal to 3. So we need to consider up to 3, so the 0, 1, 2, 3. Okay, so when m is equal to 1, there are totally t has 4 values. Okay, so when m1 t1, okay, my k value is equal to n is at 8, and t value, sorry, when m1 t is 0, so k into 0, so 2 to the power of this m minus m plus 1, so everything is 0. When m1 t1, k is equal to 8 into 1, why, because t value 1, so 2 power 3 minus 1 plus 1, that is equal to 8 by 2 square, so 2 cube, so that is 8 by 8 is equal to 1. When m equal to 1, t equal to 1, the k value is equal to 1 only. Okay, similarly for t equal to 2, for t equal to 2, k value is equal to 8 into 2 by, so 2 power 3 minus, what is the value, m value is 1 plus 1. Okay, so again this 8 into 2 by 8, which is equal to 2. When t equal to 3 and k is equal to 8 into 3 by 2 power 3 minus 1 plus 1, that is equal to 8 into 3 by 8, that is equal to 3. Okay, so for in stage 1, t has 4 values, so that k has also 4 values. So that is a k, t is equal to 0, k is equal to 0, t equal to 1, k1, t2, k2, t3, k3. Now see, in stage 2, the small m value equal to 2. Okay, now what about this t? T value is given by 2 to the power of m minus m minus 1. Okay, so 2 power 3 minus 2 minus 1, that is equal to 2 power 1 minus 1, that is equal to 1. So we need to consider t value up to 1, so 0 to 1. So when m value equal to 2, t has two values. So when t equal to 0, so what is the value of k? K has 0. Why? Because its value equal to n into t by 2 to the power of m minus m plus 1. So t equal to 0, obviously k value is equal to 0. Okay, when t equal to 1, when t equal to 1, okay, so k value is equal to 8 into 1 by 2 to the power of 3, and what is the value of m, small m, stage 2, so 2 minus 2 plus 1. Okay, so that is equal to 8 by 2 power 3 minus 2, 1 plus 1, 2 square, 2 square, that is not 4, so 8 by 4, which is equal to 2. So one is when t is equal to 0, k is equal to 0, t equal to 1, k value is equal to 2. Okay, so that is stage 2. And next stage 3. In stage 3, m is equal to 3. Okay, what about t? T is given by 2 to the power of m minus m minus 1, that is equal to 2 power 3 minus 3 minus 1, which is equal to 2 power 0 minus 1, that is equal to 1 minus 1, that is equal to 0. Okay, so here uh, m is 3, and t is 0 only. Okay, so if t is 0, what about k? K is nothing but nt by 2 to the power of m minus m plus 1. So obviously t is 0, so k is also 0. K is also 0. So these are the twiddle factors. Now we are going to determine the twiddle factors with respect to. Okay, so omega 8 whole to the power of 0, that is equal to e to the power of minus j 2 pi uh, k by n. So here e to the power of minus j 2 pi, in the place of k its value equal to 0, the place of n it should represent with 0. So e to the power of 0 its value equal to 1. So omega 8 whole to the power of 1, that is equal to e to the power of minus j 2 pi into 1 by 8, that is equal to e to the power of minus j pi by 4, that is equal to cos pi by 4 minus j sin pi by 4. So it's equal to 0.707 minus j into 0.707. W8 whole to the power of 8. Okay, so e to the power of minus j 2 pi into 2 by 8. That is equal to e to the power of minus j pi by 2. That is equal to cos pi by 2 minus j sin pi by 2. Okay, its value is equal to minus j. Okay, now see, and the last twiddle factor, that is equal to w8 whole to the power of 3. W8 whole to the power of 3, that is equal to e to the power of minus j 2 pi by 8 into 3. Okay, so it is equal to e to the power of minus j 3 pi by 4, that is equal to cos 3 pi by 4 minus j sin 3 pi by 4. Okay, so its value is equal to minus 0.707 minus j into 0.707. So this is the twiddle factors. Now we are going to design an DIF algorithm by using Butterworth diagram. Okay. So here for this DIF algorithm, so there are okay. So 8 points are there. So first of all, we should represent with these 8 points. Okay. So one is a input. Here is input. Okay. So here is output. Okay. My inputs are x of 0, x of 1, so x of 2. So we should follow natural order only. No need to follow bit reversal order like as in a destination in time algorithm. So x of 7. All samples of values are only 1, 1, 1, 1, 1, 1, 1. Okay. So now see here. Okay, so according to the step 5, in stage 1, uh, so what is that? In stage 1, so input output samples are separated by 4 samples only. So 4 samples, 1, 2, 3, 4, and it is separated by 4 samples, and it is separated by 4 samples, and it is separated by 4 samples. So here also this is separated 4 samples, 4 samples, and 4 samples, 4 samples. Okay, so my twiddle factor is so in stage 1 w8 over 0 and w8 power of 1 and w8 to the power of 2 and w8 over 3. Okay, so according to the Butterworth diagram, so what is the case? In the top side it is added with this sample 1, and which is added with this sample 1. Okay, so 1, so 1 plus 1 it's 2. 1 minus 1, its samples are equal to 0. Okay, and next one, these two samples, 1 and this one. Okay, so this is 2 and this is 0, and now this sample, So its value is equal to 2 and this value is equal to 0. And finally this sample, these two samples, its value is equal to 2 and its value is equal to 0. Okay, now see stage 1 is completed. Now see stage 2. Once again, according to the stage 2, according to the step algorithm 5, input output samples are separated by 2 samples only. Input output samples are separated by 2 samples. So that's why our butterfly diagram is adjusted like this way. Okay, so that my twiddle factor. So W8 whole to the power of 0 and this is W8 whole to the power of 2. And this is W8 whole to the power of 0 and this is W8 whole to the power of 2. Okay, again by using the same mechanism, so here this 2 and this 2 added together, so 4 and 2 minus 2, it's 0. So this 2 and this 2, they are added together, so that's why 4 and 0. All are zeros, so 0 plus 0, 0, 0 minus 0, 0, 0 plus 0, 0 minus 0. So stage 2 is also completed. Stage 2 is also completed. Now see stage 3. So stage 3. So in stage 3, according to the step 5, input output samples are separated by only one sample only. One sample. So this is one sample. Okay, so my twiddle factor is only 1, that is 0, and this is 0. So here this is 0. So for this problem, so our samples are very simple. That's why we are not. So even though we multiplied, so we should multiply with this value and which is add with this the above sample for one time and subtract with another time. So that's why we obtained this one. Okay, you should remember the procedure. Okay, so here for this one, so the 4 plus 4, which is 8, and this is 4 minus 4 into W to the power of 0, that is 0. Okay, so remaining all zeros, 0, 0, 0, 0. So finally my x of k sequence is nothing but 8, 0, 0, 0, 0, 0, 0. Okay, so this is a final answer. Okay, see for even if you have followed a distribution in time algorithm or a distribution in frequency algorithm, the result is same. Okay, thank you.